Hello everyone, this is Dr. Puigamoli, and in this lecture we are going to talk about regular expression, and specifically we want to see how we can use that in Python to manage and manipulate textual information. So first we talk about the meaning of regular expression, and then we examine different ways we can query and manipulate textual information with it. Hopefully we can take a look at some of the examples, and that help us to see what we can do to build our cleaning methodologies in the future. Many of the cleaning methodologies in Python are based on regular expression. So if you don't have Python, make sure you download it from the Anaconda distribution, and then you need to load your Jupyter notebook. You can create a specific folder for yourself to just put your notebook and any other related files inside it, or you can just use the default, which I don't suggest you to do that. Definitely create a specific folder, and every time you need any file, you can easily just go to that folder. You don't get confused with different projects or different files. Before we get to the regular expression, make sure you have a basic understanding of different Python fundamentals. There are several documentations that you can easily find and you can access to. Also, there is a specific cheat sheet you may find on internet that have some of the very basic Python code that you can refresh your memory. Specifically, we wanted to know what are the meaning of the variables, operations, how we can create conditional statements, or basically if-then statements, how we can create loops or for loops, we can create loop control statements. We have also a very important concept known as list and tuples. We just need to identify the differences, which the main differences tuples are not mutable. We also need to know how we can import output the information inside the Python environment, how we can create different functions and classes, objects, and list comprehensions are other types of very important Python fundamentals. The data structure dictionary is a very important step which might be useful when you have lots of textual information that you wanted to kind of create a dictionary for different types of documentation. So what is regular expression? It's just a very powerful string manipulation tool that is available for us. So it makes our life much easier when we have regular expression. And most of the modern language environments, they have similar library packages for regular expression. So it makes sense to know one of them. For example, in Python, if you know that, you can easily find a similar regular expression function in R and apply it. And hopefully you have that tool available anytime you want to handle any types of it or manipulate any types of textual information. So if you have a specific string or textual information, you're looking for specific patterns or keywords, you wanted to use search or match function. Sometimes, which becomes very common for us, and you're going to see that a lot, is that you want to replace part of a string. You either replace it with something else, or you just basically replace it with null, or you remove it. You may also want to break down your strings into smaller pieces, right? So if you have a very large text, sometimes you just need to break it down to different pieces, and that will be an application that might become useful for you. So the very important steps you have within the regular expression, or for short we call the regex, are three different groups. First is that you want to find specific patterns, right? Finding matching patterns in text is the first group. Second group is searching for patterns, right? So the first time you see that pattern, you're going to flag it. This is the different from the finding matching patterns, because in the finding, you are going to look inside the whole text, while in the search, the first time you see that pattern, you're going to stop searching. And finally, substituting patterns, or what we called earlier replacing, is the very important step in regex. And the regular expression is a sequence of characters that define a specific search pattern. And you want to use functions to match substitute pattern inside the text with minimum coding, right? So you don't want to create a very long code that you find a specific pattern. You want to just have one line of code that gives you that result right away. So for example, let's just take a look at some cases here. Most characters, they match themselves. The regular expression test matches the string test and only that string. So if you wanted to search for test, you are going to search for the string test, and then if that is the matching string, it's going to reply, or it's going to return you with the it is matched output. If you have X that is any one of the list characters within any of the characters of a specific list, you want to see if that is going to be presented. If you use caret at the beginning, you are going to look up for any type of matching pattern except the one that comes right after it. Dot matches any single character. Parentheses can be used for grouping, so it kind of matches that specific pattern ABC. X or Y matches X or Y, so it could be either of those. Star matches 0 or more X's. So if you have one X, that's going to be a match. If you have two X's, that's going to be another match, right? So it doesn't matter if 0, 1, or more than that would be a match. However, if you use X plus sign, that would match one or more of X. So if you don't have, like here, if you don't have any character, that's not going to be a match. X question mark matches 0 or 1 X's. So it's either 1 or 0 of that specific pattern. And then X, M, and N matches number of times X, where actually I is between M and N. So if you have A, 2, and 3, that would be a matching of 2 or 3 times of character A. Right? So for example, if you're looking for odd numbers, you can have like a even number type of pattern inside it that you're looking for. \D matches any digit, and if it's a capital D, it's going to be a non-digit. So it's a very important step in many of the regular expression manipulation, that you just need to differentiate between the lowercase d and the capital D. If you have a \F, that will be matching any white space character, and if it's a capital letter S, that would be any non-white space character. I think this is one of the very most important slides for kind of having that written down somewhere to kind of refresh your memory anytime you need that type of pattern. If you have the lowercase w, that would be matching any alphanumeric character, and if you have the uppercase w, it's going to be any non-alphanumeric character. Don't worry, we're going to see that in action, and it makes much more sense. But right now, we're just reviewing the different types of regular expression syntaxes. If you have caret, that would be matching any string at the beginning of it. So if something has a specific pattern at the beginning of that string, that's something you look for. If you have $, that looks at the end of the string. Finally, if you have \B, that will be matching any word boundary. If you have the capital letter B, that matches a character that is not a word boundary. So for example, let's take a look at this one example here. If we want to use a regular expression in Python, first we need to import regular expression, right? So we use the import RE. RE stands for regular expression, and that is the string we have. We have the A star B, and then we wanted to see if inside that string, if there is any of that pattern. The way we're looking into it is just a search. Remember, we had three types of regular expression processes. One of them was search. Now let's get to the fun part so we can actually see what is going to be happening when we run these type of code. And fun fact, I was born in 1982. I'm not that old. Be careful. And we are trying to see specific type of pattern inside that text. So what we can do is that first you need to load your Jupyter notebook and create an empty notebook, and you can just rename it regular expression Week1, and then we are going to import regular expression library, and then we create a sentence to be able to run some of these codes. So let me go ahead and open up my Jupyter notebook so we can actually run this type of regular expression functions. So there are two ways you can load your Jupyter notebook. First would be through the Anaconda Navigator, so you can actually search for Anaconda Navigator and then load that, or you can just easily load the Jupyter notebook, whichever you prefer. I always use the Anaconda Navigator to kind of make everything under the same roof, but also it's much easier to just load the Jupyter notebook directly. And when you load that Jupyter notebook, you are going to see that the Jupyter notebook will be opened in your browser. So make sure you have Google Chrome or Firefox, so you can actually implement that specific step. All right, so let's open up the Jupyter notebook. The first thing we want to do is to import regular expression library. So we're going to type it in import RE and just run that cell, and it's going to import our regular expression library. The first thing we wanted to do is to match a specific pattern inside our text. So which means that it's a local search. The first time we see that pattern, it is going to return the result. And it's not going to be, if it's a long text, it's not going to look inside the whole text. So let's create that sentence, right? So I was born 1982, and we are going to use re.match. So first type of match would be represented here, and we are going to use r dot star. Remember, dot star means that any 0 or more character would be counted. So basically, anytime you use that, it's going to be the matching pattern. And the sentence we want to use is the sentence, or SENT1, right? As you can see, it was matching, and the second matching we want to use is r dot plus, and if you recall, dot plus means that it's going to be one or more character. And if you run that, you see that there is no outcome, which means that there was no matching, right? And sentence, another sentence we can create. Let's call it sentence 2, not 20. Today is 23rd of January, is actually 4th of August. I know everyone wish it was January, but not January. And we're going to search within the sentence to any character, right? A to Z, lowercase, and A to Z, uppercase. Any, and then dot, any 0 or more. why we did not get any match. See that the beginning of the sentence is a number, it's not a character. So that's why we don't get any match here. If I change it to so today is the 4th of August, now we have a match, right? This is the match. What if we search for one or more character, because this one was 0 or more, and it's going to, of course, match the first character. Again, we are going to have a match here. If I put a number at the beginning of it, still is going to be a match. Another sentence I can create, just look up for a specific pattern, sentence 3ABBB, and then match for the pattern AB, and then if you have the question mark, means that only one B is allowed after that pattern. See if there is any match. There was no match. Okay. If I create another sentence, I was born in the year 82, and then match for that use the regular expression, match for any type of character, more than one character, and what sentence should be sentence 4 is going to give me a matching pattern. However, if you start that sentence with a number instead of the character, there is not going to be any match. So that's about match. Now search. Let's look into the search pattern. That's something we usually use, right? So we search for a specific pattern within the whole text, not just for the first time we see the specific pattern. So search for A to Z, more than one character, for sentence 4. And the first one, remember, is going to be the 5th. So we can start 0, 1, 2, 3, 4, 5. And the 5th character, we see the first matching pattern. We don't count the numbers and white space for the matching pattern, but however, we see that in the searching pattern. You can also search for specific patterns in the if-then statement or if-else statement. So if the pattern starts or begins with 1982 within sentence 4, we are going to return that starts with 82. If it doesn't, just say it does not, and you can see that it's going to tell us starts with 1982. And I can actually change, just if I run that cell one more time, it's going to be a different result. Does it end with 82? That's another question. So we can use the sentence 1, and we see that, okay, yes, it does end with 82. Because we use a $sign, it tells us that's going to be the ending pattern. So that last method is substitute or replace, which is very useful, handy for the data cleaning. So we're going to replace some patterns here. So sentence 5 is all life Avengers, and then we're going to substitute anytime we see the Avengers with Justice League. In where? In the sentence 5. So let's just run that and run the sentence 5, right? So we see that the matching pattern was replaced with another character, another pattern that we have specified. What if you have 2 times Avengers? Sentence 6, all life Avengers, and see that the Avengers pattern is replaced by Justice League. You may ask yourself why it did not replace it with Justice League. The fine catch here, you should differentiate between the lowercase and uppercase, right? So the Avengers is in uppercase, and if I do that, now it's going to be replaced with the Justice League. So I'm going to run it one more time. It's going to keep that intact. So to make it case insensitive, we can use some specific flag. And that's going to be very handy because we don't want to take a look at the uppercase, lowercase in any way. And that's going to be very confusing and it's really useless. So we are going to build that sentence 7, and we are going to, at the end of our regular expression, we are going to use a specific function known as flags, and we're going to use the re.I, which means that it's going to be case insensitive. And anytime we see a specific pattern, anytime we see any character, we are going to replace it. Remember, this is a substitute. We're going to replace it with 0. So basically, all of these characters, no matter it's uppercase, lowercase, should be replaced with 0. Let's see if it's going to be the case. That's true. Another argument is count, so we can identify how many specific characters are inside it. So sentence A is all of Avengers, and we can substitute any character with 0 in the sentence 8, starting from the second character number 2. And remember, we're using flag to make it case insensitive. So we use the characters 2, which means that, okay, so this is 0, this is 1, right? So this is 2. So up to here, we're going to replace it with 0. After that, we don't touch it. And there are some specific types of patterns that sometimes we need to handle. So sentence 9, welcome to the year 2020. Yeah, welcome to hell. Just specific type of characters arrived at @Jack's place #fun. So we want to get rid of all these symbols, and then I space love you. So let's just create this sentences first. The first sentence, we want to modify sentence 9. We want to replace any digit or just remove it. How do we remove it? We replace it with just null, right? This is a null value we can just replace it with. Let me separate it so we can actually see the result. So welcome to the year, and then 2020 was removed, right? So we replaced any digit with null. Sentence 10. What was sentence 10? Bunch of characters, bunch of specific characters. So we can identify what characters to remove or replace. And here, because of dot, we have to use 2 backslashes right before and right after it. So we can include that inside our list of symbols we want to get rid of. The next thing we want to remember, we can just have all of these in one step to kind of make it much more easy to understand. The second thing we want to do is to use the lowercase w, and then we have the uppercase W, so remove everything. So we remove everything with null, and here with the 1 empty space. And if you have any space, so if it's s, a lowercase s, if you use any if there is any space more than 1, we are going to if there is any character more than 1, just 1 character, we're going to replace it with 1 space. And finally, any single character, right? How do we identify that? Before and after that list of characters A to Z, we are going to identify the \s bar would be replaced by empty space. So let's just run that as well. Right, so we got rid of all of those symbols very easily. And finally, sentence 11, which is get rid of the space here. So we can just search for space by looking into the single character spaces, and then we replace it with just null. Also, we can replace love with hate, right? To kind of make it fun. We can just take a look at the specific pattern and replace it with something we want. And I hate you. So hopefully you had fun working on this specific notebook. The notebook will be available for your access, and I'll see you next week.